Geometry Revisited. It's kind of nice. I mean, when we first did Geometry Revisited Chapter 4, okay, the first section we looked at was actually the last section, 4.9. Okay, with the senior class. So it's kind of nice to come back here and compare it. Okay. So, genealogy of transformations. So this is going to be like summary of, for us it's going to be summary of chapter 4, okay? And some comments. It is significant that all the transformations we have seen are one-to-one correspondences on the whole set of points in the plane, yeah? With itself. Amongst these we have considered only continuous transformations or homeomorphisms. That is, transformations which map nearby points into nearby points. Okay, so more specifically, you can get the image points to be as close as an image point as you want, provided you're close enough in the domain. Okay? Alright. So amongst the continuous transformations, which are in a sense the subject of Orr's book, we have discussed the affinities or affine transformations which preserve collinearity and take parallel lines to parallel lines. Among the affinities, we have considered only similarities which preserve ratios of distances, but we have not touched upon more bizarre varieties such as the Lorentz transformations or Procrustean stretch, which takes a circle into an ellipse, okay, of the same area. In particular, similarities we have considered are isometries, which preserve distance, such as dilations, and dilations, which transform a line into a parallel line, and spiral similarities, which is a combination, right? So we did translations, dilations, spiral similarity, and like rotations, yeah, which are part of them. Okay. Okay, and the categories overlap because these are isometries. Isometries, yeah. Spiral similarities contain a rotation and a dilation, yeah. Okay. And okay, half turns are just rotations, right? And we know that too. Okay, and then they draw this table, okay, and we're kind of into the table. So there's something I think it should have been mentioned. Maybe it wasn't mentioned because it was too obvious for the author. But why did we consider these? Right? Remember at the very beginning we considered things that preserve Euclidean geometry. Right? That's what similarities was. Right? And so do you remember like if you have two directly similar shapes, right? They're related basically by a spiral similarity, right?
Yeah.
Or a translation, yeah? If they're not directly similar, they're similar but flipped, right? It's obvious that when you reflect it, they will be directly similar, right? So to get from a similar shape to another similar shape, so the kind of transformations that preserve Euclidean geometry, right? You basically can do them using reflections, rotations, translations, and dilations, okay? So basically, this is kind of saying the group of similarities, the group of transformations that's preserved similarity is generated by translations, dilations, spiral rotations, and reflections, right?
Yeah.
And I think you'll learn later that, like two reflections make a rotation. That can happen, yeah? Two rotations can make a translation. So that's the two half turns, okay? Two translations obviously make a translation.
Yeah.
Two dilations make a dilation if it's the same point.
Yeah.
If it's a different point, what happens? Well, it's a spiral similarity still, isn't it?
No. But it's not like translation as well.
Yeah, so it could be translation as well, yeah?
Yeah.
It's included. Okay, so That's kind of the point, yeah? It's kind of like, when we're learning trig, it's like we just have a random list of formulas. Why do we have them? Well, that completes the program for all these things that are related, right? So this completes the program for the transformations which preserve similarity, okay? It doesn't tell you what each of them are, but it tells you they're built up by these pieces, okay? All right. So some of the final exercises, I mean, it might be... did you do them?
Wait, what exercise?
So translation takes 0, like the formula for the translation that takes 0a to 0ab. So, it's like x, y goes to x plus a, y plus b, right? Yeah, we might skip some of the ones we did last time. A central dilation about the origin of factor k. So that's obviously k times, yeah? If you want to do a half turn about the origin, that's obviously the negative. Okay, so it's the same as timesing by I twice. Yeah.
Yeah.
So it's negative. A spiral similarity, which so about the origin with ratio k at 90 degrees. Yeah. So now you're timing it by ki twice. Yeah.
Yeah.
So you get not ki twice, ki once, yeah, ki once. So you get what happens if you times it by I, yeah? 90 degrees. So the y, that's the imaginary part, right? It's x plus iy, yeah.
Yeah.
So if you times it by I, you'll get minus y plus ix, yeah.
Yeah.
So it's minus y, and then you have to times it by k, right? And then it's kx here, right?
Yeah.
Okay, and a symmetry that has not yet been mentioned. It's hard to do that one. Did we do reflections? We haven't done it. Not mentioned where. The continuous transformation. I think we talked about some of these in other situations, but my goal wasn't to really completely go through these. I wanted to add that like there aren't some other ones that we missed, like the other ones are gotten by, there's other geometries apart from Euclidean, but the Euclidean ones are gotten by composing these. Okay. Yeah, so that's the end of chapter 4. And chapter 5 is inversion, okay? So an inversion is like a transformation, so it's kind of good to have an idea of what transformation is. Okay, so yeah, let me just end that there.